Okay, hello everyone. So this video we're going to enter 9.2, chapter 9.2 on rates. And it's a little bit different from ratio. And in under rates is actually a very long subtopic. So I'm going to break this big topic down to a few subtopics over here. And today we are going to look at the first basic ideas about rates, right? And what are actually rates? They are different from ratio. Ratio, we will compare things of the same kind. For example, if you look at this distances, then the three quantities are distances. Or the questions that we've seen before are relating to money. So every quantity over there is money, money, and total money, that kind of thing. But for rates, we are going to look at we're going to compare between more quantities, but and then the quantities will be different. So over here, what are rates? They are actually comparisons of two or more quantities of different kind, right? So they are comparison of two or more quantities of different kind. So what does it mean? Means that instead of just comparing length and length, we're going to look at length and mass, we're going to look at mass and volume and so on and so forth. Right? We're going to look at money to something else, money to per liter, money to per meter square. So we're going to look at different quantities meshed together. So one example that I can give would be something that you've learned in science. Do you know the unit for density? Density is a unit of G slash cm cube. So normally how do we read this thing? This thing reads grams, how many grams per centimeters cube, or grams per cubic centimeters. Alright. So the thing is over here, right? This word per. This word per over here actually means it's for every. For every, or we will normally take divided by. So over here, we'll take grams divided by centimeters cubed. Okay, grams divided by centimeters cubed. So it's actually consistent with your formula. Density equals to mass over volume. So mass is in grams, volume is in centimeters cubed. So mass divided by volume. And this division actually gives us one form of a rate. Okay, so we have other forms of rate. For example, in a taxi, for every km that we travel, they're going to charge you a certain amount of money. So dollar per km. So these examples are the ones that will give us rates. And they work the same way with ratio. We can make use of the ratio method or the unitary method where 1 unit is this, 5 units that. We can make use of these methods in our calculation. Okay, but at the same time, let's look at two very important, I call it formula for rate. Okay, so the first formula over here is that for to calculate rate, usually we take amount A, right? So we'll take, like, for example, mass divided by amount B, will be volume. So mass over volume will give us one kind of rate. Okay, another example of rate would be a distance over time, right? Distance over time would be two different things, and the result will give us speed. Okay, so with this, another way of saying rate, right, is, for example, how fast are we doing things or how slow are we doing things. So whenever we talk about how fast or how slow, one of the quantity that involved is time. So over here, we also have rate is equals to the amount of things to be done, or the amount that we are looking at. Right, the amount that we're looking at, we will divide it by time to see that whether is it fast or slow. Okay, so over here we have two important formulas for rate. Okay, rate being amount A over amount B, or any generic amount over time. So these are our basic ideas about rates. So without further ado, let's go on to practice now 9 in page 49. Let's take a look at this over here. So we have Li Ting can type 720 words in 16 minutes. Vani can type 828 words in 18 minutes. Ali can type 798 words in 60 minutes. Who is the fastest typist? So we will, in order to look for the fastest typist, it will be good to convert all this to 1 minute, and let's compare and see. Right? So we have two methods over here. I would recommend method 2, but I will show you what you have done previously. Okay, so in method 1, you have Li Ting, and Li Ting started off with 16 minutes with 720 words. We can divide it to 1 minute, so 720 divided by 16 would give you 45 words. Right? So we divide by 16 on the left, we divide by 16 on the right, as you can see here. Right? So divide by 16, divide by 16. So this is what we did in primary school. Okay, next we look at Vani. Okay, so Vani started off with 18 minutes. 18 minutes, and she has 828 words. So let's divide this by 18 to get 1 minute. So divide by 18 on both sides, we have 46 words. Okay, so in 1 minute, she can type 46 words. Next, last but not least, we have Ali. Ali, 19 minutes. 19 minutes, 798 words. Okay, and let's divide by 19. So this divided by 19 will give us 42 words. So who typed the most amount of words in a minute? And the person will be the fastest. So who is that? The person is Vani. So Vani is the fastest. So this is what we did in primary school. Okay, Vani is the fastest. So this will form method 1 using the unitary method. We call this the unit method, or we call this the ratio. I'm going to call it the ratio method to look at 1 unit. Okay, now unitary method. Now number 2, method 2, I'm just going to go for rate, and I'm going to make use of the formula. Rate would be equals to the amount that I have divided by time, because this one is, since we're looking at like time. So let's take a look at Li Ting. Okay, so for Li Ting, we have 720 words, right? And then we have 16 minutes. So this would be 45 words per minute. Do you see this? 45 words per minute, WPM, right? For Vani, we have 828 words, and over here we have 18 minutes, right? 18 minutes. So here we are going to have 46 words divided by minute, so words per minute. How 46 words every minute? Okay, because we're dividing by 18 anyway. Last but not least, we have Ali. Ali would be 798 words divided by 19 minutes. So this will give us 42 words per minute. Okay, so because of this, who has the most amount of words for every minute? Vani will be Vani. So Vani is the fastest typist. Okay, right, so these two methods over here, the first one is unitary method, the second one making use of rates, or making use the formula for rate to calculate certain things. So up to you. I'm going to leave it up to you. For me, I would definitely prefer method 2, and the reason why I prefer this is actually like sometimes I can chain rates together. I can make use of some calculations, make use of this to do some calculations. Okay, so but we'll see that when we come to it. Okay, so let's take a look at practice now 10. Let's move on to practice now 10. So we have a survey conducted in 2015 to find out the literacy rate among the resident population in Singapore. So the literacy rate is calculated by dividing the number of residents who are literate by the total resident population aged 15 years and older, and then expressed as a percentage. Okay, very mouthful. Very, very mouthful. So what do we mean by literacy? Literacy means the ability to read. Okay, so we are looking at the percentage or the rate on how many people are able to read well. Okay, and they give us the formula above. Okay, so they gave us the formula. So literacy rate, okay, over here, in the second sentence, is calculating by all these things. Okay, so it's calculated by dividing the number of residents who are literate. Okay, so number of literate residents. Okay, and we divide this by the total resident population. And we express this as a percentage, means I'm going to multiply this by 100%. Okay, so this is the formula that we have over here. So results of the survey found that the literacy rate was 96.8%. So let's explain what does 96.8% means. So the percent actually comes from 100%. Okay, and for 100% we can assume that we're going to refer to 100 residents. Okay, so 100 residents total. So how many of them are literate? 96.8 of them are literate. Okay, so one way that I can write it is for every 100 resident, for every 100 residents, right, there are 96.8, so there are 96.8 residents who are literate. Okay, or let's say if you're not comfortable with 96.8 people, because how on earth can you get like 0.8 people? Okay, so if you're not comfortable with that, let's go for another layer. So for every 1,000 residents, right? So if we were to refer to 1,000 residents, what does it mean? We have 968 of them being literate. So who are literate? Okay, literate means able to read. Okay, so these are a few ways in which we can express what does a rate mean, right? So for every km we have this, every dollar we have that, every cm cube would be this. Yeah, so this is what we mean by rates. Okay, now let's look at practice now 11. So we have chocolate drink powder, 2 different sets. Which tin gives the better value for money? So we're going to look at 2 methods over here. So method 1. Okay, so for method 1, because we're looking at mass and money, right, the amount of powder and money, so I'm just going to like divide and see every dollar how much powder do I get. Okay, so for the smaller tin, right, so for the smaller tin, because I want every dollar, so I'm going to take 900 gram. I will divide this by $12.50. So this will give me 72 gram per dollar. Okay, so gram on top, dollar below, so gram for every dollar. Okay, so the bigger tin, what about the bigger tin over here? The bigger tin would be 1.45 kg, or let me change to gram so that it's consistent with what I calculated up there, and it's costing me $17.90. So post calculation, this will give me 81.0 grams per dollar. So for every dollar, I'm going to get 81 grams. So every dollar, which one would give me more grams? The bigger tin. So therefore, the bigger tin is more value for money. Alright, so let's take a look at method 2. So for method 2, instead of looking at how much powder per dollar, I'm going to look at how much does it cost for every unit of mass. Okay, so for example, if I were to look at the smaller tin, okay, so you can definitely use your unitary method, like the arrow thingy. For me, I'm just gonna like do this division and just calculate. Okay, so over here I have for the small tin I have $12.50. Let me divide this by 900 gram. So this divide by 9, so this is going to cost me $0.01389 per gram, for every gram. Okay, so this amount of dollars per gram. Okay, what about the bigger tin? So the bigger tin is going to cost me $17.90 for every 1450 gram. So dividing through, I'm gonna have $0.01234 per gram. Okay, so for every same gram, which one is cheaper? So the cheaper one would be the bigger tin. So the bigger tin is more value for money. So do you see how the logic works? Right? So we look at for every dollar, how much can we get, or for every unit, how much does it cost. Okay, so these two are two different methods. But both, as long as you can identify the correct identify the correct variables, you should be okay. Alright, so let's take a look at our last practice now for the day. So the last practice now for the day would be in practice now 12. And we are going to look at question 1, question 2. For question 1, a bus company charges $2.70 per kilometer to ferry 36 children for an outing. So the accompanying teacher travels for free. So what is the cost per child if the distance traveled for the trip is 32.5 kilometers? So we have two methods over here. I'm going to present you two methods over here. So method 1. Okay, so method 1 is going to make use of our unitary method, and I think like when we have two or more, maybe three or more quantities, I think the unitary method would be better. It actually keep tracks of things clearer. So let's take a look at this. So a bus company charges, so a bus company charges, so we have $2.70. This is tied to for every 1 km, and this is tied to 36 children, right? 36 children. Okay, so this is the rate that we have. So the teacher not counted because it's free. So I'm looking for the cost per child. Okay, cost per child, and then you change the distance to 32.5 km. So let's travel for 32.5 km first. So I'm going to make this 32.5 km. I'm keeping the number of children the same, so 36 children, I'm keeping it the same. Okay, I'm going to see how much it costs. So if I multiply by 32.5, it's going to give me 87.75. Okay, so this is my second set. So when I do this method, I'm going to keep the rest constant, and I'm going to change pair by pair. Alright, so now with this set already in mind, so I'm going to look for the cost for one child. So let's divide this into one child. So I need to divide by 36. So which one do I divide? Do I divide the distance or do I divide the cost? I'm looking for how much does it cost. So I'm going to divide by the money by 36. So dividing the money by 36, I'm going to have $2.44. Okay, for the same 32.5 km. Okay, so this will give me so like that. So the amount that I'm looking for is the cost per child is going to be $2.44 per child. Okay, so this would form method 1. Okay, so let's take a look at method 2. Okay, let's take a look at method 2 over here. I'm looking at cost per child. Okay, So cost per child. So indirectly, my desired fraction would be the cost divided by how many children. Okay, so the children needs to be at the bottom, the money needs to go on top. Okay, so let's take a look over here. So we have okay, so over here we are going to have $2.70 per kilometer. So I'm going to divide by 1 kilometer. Okay, and I'm going to multiply this by 32.5 km because this would be for 1 kilometer, and I'm going to multiply this for this amount of km. And last but not least, I'm going to divide this by the number of children. I'm going to divide this by 36 children so that I can get like 1 children. Do you see how it works over here? Okay, I'm going to get like this amount of children over here. Okay, so $2.70 per kilometers, right? Per kilometers. And then I have 36 children. I'm going to divide by 36 children to get my 1 child. And I'm going to multiply the whole thing by 32.5 km. So if we were to compare the units, so let's check the units, does it tally? So kilometers and kilometers can cancel. So I have a dollar on top, the children at the bottom. So I can do this multiplication, and this should also give me $2.44 per child. Okay, so technically speaking, we can use fractions, we can chain them together, and just need to ensure that the extra things are being cancelled away. And we are going to get dollar on top and the number of children below to get our cost per child. Okay, so this is how it works. All right, so this is how it works in the unitary method or the chain multiplication method. So for me, for this, I'm going to recommend method 1 instead. Okay, it's going to be familiar to primary school, and when you juggle, you just need to make sure to juggle pair by pair. Okay, so that you are not lost. Okay, let's take a look at B. So B, a car uses 25 liters of petrol to travel that amount. Find on average the distance the car that can travel on 58 liters of petrol. Okay, so let's take a look at this one over here. So we have 25. Okay, so I'm going to look for method 1. Okay, method 1, the unitary method. So I'm going to have 25 liters of petrol, and then I travel 265 km, right? So over here I'm looking for on 58 liters of petrol. So 58 liters is going to cost me 265. I need to divide the 25 to make 1 unit, 1 liter, and I'm going to multiply by 58 for the amount of liter. So this will give me, interesting. Okay, so this will give me 614 points. So this is going to give me a 614.8 kilometers. Okay, so what does the question want again? The distance that the car can travel on this amount. So I'm going to get this amount of distance. Okay, now let's take a look at method 2. Okay, so method 2, I'm actually looking for distance traveled. Okay, so I will need to start with distance traveled over here, and I'm going to need to cancel the rest so that I'm only remaining with distance. Alright, so let me start off with 265 kilometers first. Right, so 265 kilometers we are traveling based on 25 liters, so the liters will be at the bottom. So in order to cancel my liters, I'm going to multiply by 58 liters over here. Instead of dividing, so I need to multiply by 58. Okay, so actually can you see that this fraction and that fraction over there, are they the same? 265 times 58 divided by 25. They're actually the same. Okay, and in the end of the day, I'm going to get 614.8 kilometers over here. Okay, so when I play by fraction, one at the bottom, one on top, I just need to find things that cancel each other nicely. Okay, so this is going to be part B. Now let's take a look at question 2. So we have a competition and we have 50 people eating 20 steam buns in 3 minutes 20 seconds. So assuming everyone consumes steam buns at the same rate and the rate of consumption remains constant throughout the competition, find the number of steam buns 10 people can eat in 5 minutes. Okay, sure. So we're going to look for our unique method over here. Okay, we're going to eat buns. Okay, so let's start off with 5 people, right? Munching 20 buns, 20 steam buns. The time is going to be 3 and 1/3 hours. 3 hours 20 minutes is going to be 3 and 1/3 seconds. So 3 and 1/3 minutes. Okay, so 3 minutes 20 seconds. Okay, so we are going to look for 10 people. Great, 10 people, and we need to look for number of buns. So number of buns we need to keep changing, but I'm going to make this 10 people first. So the thing that is going to change is the number of buns that are going to change. So 5 people eat 20 buns, 10 people are going to eat 40 buns. Okay, and in the same time they can eat 40 buns. Okay, so once my 10 people are done, okay, I'm going to change the time. So instead of this one, I'm going to make this 5 minutes. So 40, right? So 40, I need to divide by 3 and 1/3. I need to multiply by 5. So this is going to give me 60 steam buns. Okay, so the number of steam buns is going to be 60 steam buns. Okay, now so with this, let us explore method 2. So method 2, if you were to use your multiplication, make sure you write down the units clearly, okay? So if you're using the multiplication, how will it look like? Okay, so we have okay, so I'm looking for the number of steam buns. So the number of steam buns would be on top. Okay, and I'm going to start off with 20 steam buns first. Right, 20 steam buns. Okay, I'm going to divide this by 5 people, and I'm going to divide this by 3 and 1/3 hours. 3 and 1/3 minute. Okay, divide by 5, divide by 3 and 1/3. Okay, so I can get the buns per person per minute. Okay, and afterwards I will use this to convert this to 10 people, and I'll convert this to 5 minutes. Oh dear, not enough space. Okay, I'm going to convert this to 5 minutes. So now, if you were to look at the units, you can actually see that the people and people cancel off. The minutes and minutes will cancel off as well. I just need to multiply all these numbers to give me 60 buns. 60 steam buns over here. Okay, so now, if method 2 is too fast, it's okay. I would definitely recommend method 1 more than method 2. Okay, so this will end our video for rates. So hopefully this variety of questions will give us the tools and the awareness that we need to solve questions involving rates. Okay, so moving forward, all you need to remember is the most important thing regarding rate, which is the formula for rate, which is amount A over amount B, or any amount divided by time if you're looking for speed. Like how fast are you doing certain things, or how fast are you spending money. Okay, so that's all for this video, and thank you for surviving to the end. I wish you a good day, and remember to do your exit pass. That's all. Bye bye.